Today I'm talking about verifiable credentials. My name is Maki Kato. I'm in the IT field. I do software. I've done programming since I was a young age, and I like old computers. In particular, my focus, as I gotten older, I've sort of focused on things, and my current focus is on the Motorola 88,000 processor based systems, and this was a processor that was between, well, it came after the RISC and the Spark, and it sort of led into the PowerPC, so it's early 80s, no, mid 80s. And so I collect those processors, workstations, and I also tinker with, I grew up on CPM and Z80, so I tinker with that stuff too. I do mostly software. I like to tinker with hardware. I love restoring old machines, and this has always been a passion of mine. So, and then on the times when I'm not doing computer stuff, I like to get outdoors, and I climb rock, and I also climb trees. There's a picture of me doing tree climbing. That's my buddy Crawford in the background there. But anyway, so I do that sort of stuff. Okay, so today's presentation is about this technology called verifiable credentials. It is a brand new technology. It's up and coming. I think it's going to be groundbreaking. It involves a lot of crypto, so it is no way something that will run on old hardware. So I'm not talking about running this on old hardware. In this particular case, I want to apply the technology of verifiable credentials in the community to do something interesting or useful with that. And so I figured I will talk about what verifiable credentials is so that we can have a common understanding. And then maybe at the end of the presentation, we can open up for brainstorming if people have interesting ideas, or otherwise I can discuss a couple other ideas that I had that might be relevant to the community. So that's where this presentation is going, and let's get started. So verifiable credentials is about fast automatic verification of facts. So the automatic part is really a key. There's lots of ways today to verify things that don't scale, and it isn't that fast, and it's not that convenient. So this is a whole new reinvention of a system to verify facts. What kind of facts? Any kind of facts, really. Proof of age, residency, like a driver's license, membership, travel-related documents, health-related information, you name it, we can probably encode it into a data structure that we can pass around and then at downstream verify. But the features here that are important are that it's instant, that it's secure. In particular, it also allows the credential holder, which is the person that holds the fact, to be in control. So he actually she will be able to share that credential as needed on his term, her term. And then privacy preserving wherever possible, and portable, and one implementation for many signers. I'll sort of touch on this aspect a little bit later because I think it's kind of important and different from how things are done today. Okay, here, so this is the classic triangle. This is the summary of the whole talk here in concept. The issuer will issue something about a fact about the holder. And sometimes this is called a credential, and sometimes it's called an attestation. There's lots of terms about this, but the idea is that the data holder, let's say it's me, I have something that, let's say my driver's license, if that was digitized, the issuer would be my state government that issues the driver's license, but I get to hold, just like in my wallet, I will have a driver's license that I control. I can decide who I share that with. And then the verifier is anybody downstream that needs to verify. In the case of a driver's license, it could be like a rental car company. They want to be secure about knowing that I am a licensed driver, for example. So, and today, there's physical objects that do this job. The verifier would then ask for my driver's license, and I would share my driver's license with that verifier, and he will sort of inspect it visually and make a decision about, whether to trust it or not. The digital corollary to this would be that, the verifier will look at the, and we'll talk about verifiable credentials. So let me back up a little bit. The issue is going to issue the verifiable credential. And it's going to be issued about something. So in the case of the driver's license, it'll be the local government is issuing a driver's license to the holder, which is the subject, and that would be me. But the verifiable credential would be issued by the government. I get to hold it, so once it's issued, it's in my possession, and at a later date, somebody may request to see that credential, and I'm able to share that with the verifier. The verifier will then, it's a data structure, so he will look at that, and in there will be some signatures which stand as proof that the credential is issued by who it says it was issued by. The beauty of this system is that the verifier actually does not need to talk directly to the issuer. So this is good for scalability because you don't have to bother the issuer. The issuer just needs to have his credentials findable and his public key that he signed. Then all this is based on public key cryptography and signing and like that. The verifiable credential stuff is already a accepted standard by W3C, and this is the VC data model, which is sort of the core of this whole ecosystem. It is an ecosystem. There's lots of aspects to it. So a credential can be written about lots of different things, and there are already some sort of templates for these things. For example, there's a certificate, like an educational certificate. There are membership certificates. There are like driver's license, and so on and so forth. So there are templates about these already published and accepted, fairly well accepted. Okay. Oops. Yes. The verifiable credential is going to be written, or attestation is going to be made about a subject. And that subject needs to be represented somehow, and the basic building block for all of this is going to be this data structure or notion called DIDs, D-I-D, standing for decentralized identifiers. This is basically the endpoints, or it can be an endpoint in a communication. It is definitely the how a subject is denoted. The DID is actually a reference, and the bottom there is just a little, this is what a DID looks like if it was represented in text, and which it is, but it's meant for machine consumption, so it's going to be something like DID : and then there's a method. Right now there's already 100-some plus methods of basically where to find the DID document. So the DID is a reference to the DID document. The DID document is a JSON document that has attributes about the DID, and basically the DID is sort of the pointer or the URL, the URI for that thing. So it'll look like DID : SOV : and blah, 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 which would be a hex string representing the hash. So this also is already well defined, and there are ways to record the DID document and how to find it. The method is really the encapsulation of how to find it. Unfortunately, right now, if you come up with a new place to put this DID document, you're going to have to come up with a new method and then add that to the standard. But there are well-published standards of where to put things. Okay, and then the communication between all these systems can be done in a traditional REST-like API, which will be synchronous and it's sort of web-based, as well as there's a new communication protocol for all of this called DIDCOM, and it is more message-oriented, inherently asynchronous. It has, by design, it could use any transport, and in fact, actually, you can have multiple channels, and your reply can come back on a different channel, or sometimes not at all. But nonetheless, there is another standard that's being built for this purpose called DIDCOM. All right, so all that was quite abstract, and let me see if we can get a little more. So when I first learned about verifiable credentials, one of the questions was, okay, so that all sounds good, but what's the user interface going to look like? Because that's really how I'm going to relate to all this technology. So the core of the user interface, at least conceptually, is it's going to feel like a wallet, and probably many of you already are familiar with the wallets on the mobile smartphones, and that is probably where all your credentials are going to go. On a smartphone, most likely, and the interface between system and you will most likely be a QR code. So a website, if it's going to ask for your verifiable credentials, would just pop a QR code in front of it. You're going to pull your phone out. You're going to switch to the wallet and scan that. That QR code is going to represent really a request for a verifiable credential, and that request will then trigger your phone or your agent, and I'll talk about agents in a second, to asking for that credential. And you will then be prompted, your phone's going to ask you, this entity is asking for this information from you. Do you want to share that with that entity? Now, one of the cool things about verifiable credentials that you can't do with your physical credential is that you can actually you can pick and choose the fields you want to share. So again, back to the driver's license, which is still hypothetical. But in your driver's license, you go to a club and you get, at the entrance, you get carded. You present your driver's license. Nobody takes a birth certificates to the club. And so you end up, the most convenient thing to do is to show your driver's license. But at that point, you're actually already sharing your birthday, your address, and your photograph, which not all of that is necessary for verifying age. And in fact, actually, the other cool thing about verifiable credentials is there's a way to verify an attestation without sharing the actual data, which is sort of built on top of what's known as a zero-knowledge proof. It's sort of a crypto term. Mathematical technique. Nonetheless, the point is that if you just need to verify that the person is over 21, you can do that without sharing your birthday. And that there is provisions for doing such things with the verifiable credentials, which is good. It's privacy preserving. And anyway, back to the user interface. You're at this point. They're asking for, and in the request itself, you can formulate what you're looking for. So the other party is asking for, say it was a proof of age, in which case then the wallet can actually formulate the response and withhold the address, withhold the actual birthday, if the other party can understand the zero-knowledge proof stuff, and just share the fact that you're over 21. So that's the smartphone-based UI. If you are doing, there can be a user interface, and this is where there's the notion of cloud agent. And by the way, when this becomes commonplace, we're talking thousands of verifiable credentials flying around. You will have a lot of credentials in your possession, probably. Of course, you'll start with one, but you'll accumulate lots of stuff. It makes sense to actually store these credentials somewhere, not necessarily only on your phone. So there's likely going to be either a service, a server process, or an agent in the cloud representing you that's always on, and that would be the cloud agent component. This is probably going to be a service. It could be a service that's provided through your phone company, if that, not phone company, but so, Apple will probably be in this business, is what I'm trying to say, as well as, Android and so on and so forth, Google, I guess. But you may likely have options on that front. The benefit of this, of course, is that your device is not the only source, so when you happen to drop it in the lake, your phone, when you drop the phone in the lake, it's not over, it's not game over there. You can somehow recover stuff. There's also lots of provisions for how to keep backups, how to store backups, and how to do all that stuff. A lot of thought has been going into this already. Let me talk just a little bit about what I call networks in this case. So remember back to the did slide, there was did : SOV : and then the string, the method part. That's really where the did document is stored. That ends up being, it turns out very convenient to put these things on what's known as digital ledger technology, which is another word for blockchain. So this is a blockchain app. It's very convenient to do so because the blockchain, and the blockchain is the network, built into the blockchain is governance. So not everyone can read and write to every blockchain. So you actually, depending on the blockchain, and there's one software system called Hyperledger, Indy, which is an open source project. I guess it was initially started by IBM. That is basically a blockchain. Hyperledger Indy is an identity blockchain, and in order to record identity-related stuff on that blockchain, you need to follow their rules, and which is helpful because at this point, the issuer needs to be first of all findable and also sort of somewhat trustworthy. So if you don't want random people claiming that they're the government entity and issuing credentials, you want to be able to, with a very high degree of certainty, know that the issuer is who they say they are. So it helps to record that on a blockchain where it's auditable and it's public and findable, and there's lots of good properties about blockchains that distributed, among other things, and decentralized. But it doesn't mean that DIDs only have to live on blockchains. You could put it in a database, and you'll have to, work with those, the consequences of that. So long as so long as the verifier can find the issuer's DID, then it could be anywhere. And in particular, there's also a scenario where you don't want to disclose the DID to anybody else. It's just a DID really, at the end of the day, is it's a public key and private key combination that you can use for communication. So if you want to encrypt the channel, both parties basically exchange their public keys, and then you can have a secure channel between the two people, but that could be the end of it. Right? Those two DIDs serve no other purpose other than to allow for the communication of those two parties securely. And in such case, there is a method for those DIDs, a method called peer DIDs, I'm sorry, that allows for just that. Okay, and just a side note, or a very important side note, that you may be wondering I don't want to put my private information on the blockchain, and nobody's saying that you, in fact, everyone's cautioning everybody else to never put private data on public blockchains. So That's that. Because the DIDs now have the method specifier, it's now possible to do cross-network verification. So you could be a verifier that doesn't deal with that other network, but potentially if the issuer that you want to do business with is on a different network, that can now be done mostly as a functionality of the resolving the DID, which is another piece of software that does that. So that is a little bit about networks. So there's a number of networks that are already online. But before that, let me talk about the verifiable credentials. So ultimately, this is what we're talking about. The verifiable credentials ends up being basically a JSON linked data format. So there's a well-defined format for this. It might look like this. I'm sorry about the small print, if it is. I'll just give you the highlights. In these verifiable credentials, there will be a type, very important, so that it's a verifiable credential as well as it's an example. In this case, it's an example credential, but it could be sort of like a certificate. And then there's an issuer, which is basically the DID for the issuer, and that's the part that if you follow that, you'll get to the public key for the DID, for the issuer, which is then going to be used for the, later down there's a proof, and I sort of cut the rest of that. But in the proof, there will be actually the signature attesting to whatever the fact is that this document is about. Okay, the key takeaway here is that it's a JSON document and it's well defined and there's a lot of flexibility to it. Okay, so back to the triangle. I just wanted to highlight some of the steps that and then also, so the verifiable credential is issued and signed by the issuer and passed on to the holder. So this is going to happen, basically you go through some steps. So let's say it's a lab result that has, that says that you've taken a PCR test within the last 24 hours, which the verifier downstream might want to know for whatever reason. The lab will take the lab results, formulate it into this document, and sign it. The lab actually will sign maybe with its own key, which you may not trust the lab directly, but you may trust an entity that then sort of certifies all these labs, and then that will allow for these entities to come online without you actually needing to change anything on your end. You just, so long as you trust the what's the auditing or the authorizing entity for the lab, so that you can follow the chain of trust to end up at being able to trust ultimately the credential. Okay, so the credential data structure is kept in your possession, and then when you are requested, it actually produces a different document. So what the key point here is that the VC and the VC presentation are not the same thing. The issued VC is actually has a lot more information, and what you present is up to you at that time, but there is a way to formulate that while preserving the proof, which is the part that the issuer issued. So that's what that diagram is. Okay, so there's the big question of where are we at with this stuff today? How far out are we talking about, or how concrete are these things? There's several open source projects. I follow the Hyperledger Indie stuff, so I'm going to call out that a number of times. But Hyperledger Indie is an open source project funded by the, at this point, Hyperledger Foundation, and Indie's just one of the products in that catalog of things. And Aries is, Hyperledger Aries is a component that Indy is the blockchain aspect that can hold the identity and hold the DIDs, whereas the Aries is the rest of the sort of software components, including potentially the wallet and the cloud agents. So those are already written. You can actually write, you can write systems today that use this and that perform fairly well. And I hear of, there's a lot of reports from the, I guess Aruba is using this at a pretty large scale for verifying travel documents and also for verifying, they used it during COVID for verifying the PCR tests. So, so that's it. So, and then there's other government level activities that are in play, not necessarily by Hyperledger Indy. The identity part is stored in a different network. And I guess I didn't mention this, but you can have, there's ways to do verifiable credentials with existing identity models. So something like a Google identity or a Microsoft, Azure AD, that sort of stuff, those are known as federated identities, and you can use verifiable credentials with federated identities, or you can use verifiable credentials with otherwise known as self-sovereign identities, where the identity is sort of more decentralized and less controlled by one entity, one company, that sort of thing. On the more proprietary side of things, Microsoft has a product line called Microsoft Entra, which is what I just mentioned. It's the verifiable credentials built on top of Azure AD, and they have pretty extensive software today that you can just go ahead and configure and start issuing membership credentials. So for a corporation to issue membership credentials, the motivation there is that then they can just basically pass that to each of the employees. The employees can then, if they need to get like, corporate-based membership, corporate membership-based discounts or benefits, the third party that's implementing these benefits, all they have to do is, use Microsoft software to verify that issued, basically employee credential is still valid today, and that can be done instantly. Without, I don't know what you would do. I guess you'd, today, if it wasn't for that, you would take a picture of your company ID and mail it to the third party so that you can get the discount, something crazy like that. Or they already have a web system that allows you to do that. But the beauty of the VC is that the web system doesn't need to communicate in the back end about who the valid employees are at that week or that day or whatever the case is. So, so there is some use cases that are already of interest to people and that have been implemented, and that's where all this is today. And wallets. If you go to the Apple Store, the Android Store, you can find dozens, if not hundreds, of wallets already. And there are if you Google for verifiable credential companies, you'll see at least 20 or plus companies already in the market. So, so then what's going to happen next? This is sort of this is the big question, right? I think all of this is going to take off, and when it does, it's going to have a network effect, which is to say, once there's more verifiable credentials, then you can build on it. For example, banks are talking about, banks have this requirement called Know Your Customer, and it's abbreviated as KYC, which is a funny acronym in my opinion, but they have this requirement that they must verify customers, and so they do that. Every bank does it in their own way today, but there is talk about banks sharing this KYC about you, such that so a bank can issue you a verifiable credential that has basically the stuff that bank wants to know. And then if you go to apply for a loan at a different bank or need to open an account at a different bank, that you could share potentially that verifiable credential and not have to do the paperwork all over again, which sounds attractive to me. And it's the information that you have to share anyway. They're going to ask the same stuff. So that makes sense. Like anything else, need is going to drive adoption. And it seems to be in the United States, there seems to be a lot of need for age verification at convenience stores. So this is what I found. That there's an association that is a collection of convenience stores, and they are about to roll out a mobile app that is built on verifiable credentials that is going to help with age verification everywhere. That you have to show that when you first initialize the piece of software, you're going to have to present it with your driver's license, but then the attendant or the clerk can actually scan your driver's license, scan your QR code, and basically make an attestation that they verified your age and your photo, and everything matches, and from there on, you can just show your QR code from the mobile app to to prove that you're a certain age. And I don't know if they're using zero knowledge proof on that one, but I could easily imagine that happening in the future. Really, so outside of the United States, I hear that travel-related documents between countries, like in Europe, is a really an area in which there's a lot of need, so that people are very interested in somehow using this technology in travel. So I hear about that. But anyway, when it happens, I think it's going to happen pretty quickly, and hopefully that'll be fairly soon. Okay, so I want to, at this point, do a little recap and then get into the actual discussion part. And if you have questions at this junction, I'm happy to answer those. We talked about, what did we talk about? We talked about the trust triangle, so there's going to be the three parties, there's going to be somebody that's going to issue a attestation about a subject or about you, and you will receive from them a verifiable credential that you can store in your wallet, and then at a later time, you can present that to whoever you want to present it for whatever purpose, the verifiable presentation to the verifier, and the verifier can check to see that it is what you say it is, whether that be a lab result or a age verification or an address verification or whatever the case is. Okay. So those are the things we covered. Any questions so far? Yes, go ahead.
First of all, thanks very much for the URL. Version 2 came out 2 days ago.
Yeah, yeah. The data. What was it? The data model, right?
Yeah.
It's a draft, but yes. So they're definitely moving forward on that.
It looks like it does cover the really important things of the issuer, the kinds of things that you have, and your ability to sort of say, no, I've got all of these different attestations, and I'm only going to share this little bitty one with you because if you get too many of them, you can actually identify me by sort of assembling those pieces.
Yes.
It seems like the crux of the security issue is the wallet. And you have to make sure that nobody steals your wallet. And in fact, I guess in the trust model, it says that we rely on the repository to securely keep those verifiable credentials and only give them to the owner.
Yeah, that's exactly right. A lot of it hinges on that, which is, I guess you're probably familiar with the banking apps, for example, on your mobile phone. It asks for your fingerprint every time you open the app, and that it'll require that sort of level of trust. And there's some speculation that today the app is, the wallet function itself is sort of an external app. Speculation is that will that could possibly become core to the operating system of both of these smartphones. And then the actual secrets can sort of reside in the hardware, in the secure store, that sort of stuff. Yeah. Right, yeah, go ahead.
You mentioned zero knowledge verification. If you were to issue two queries, older than 21, and then issue a second query younger than 22, then you would be able to figure out.
Yeah, so the question is, I guess you can triangulate the actual birthday by repeating a zero knowledge query, and I don't know the answer to how you would avoid that. I guess possibly it's predefined, and the other thing is you don't have to answer all those, right? Ultimately, they're gonna have to make another request for a verifiable presentation that you can decline, I guess, or you could be suspicious about why they're asking all these, repeated questions, I suppose. Yeah. Okay, so let's move on a little bit. So can this be useful? And specifically in the vintage computing community, and I came up with a couple ideas that that I think might be of relevance. And one was that hard drive that we talked about. And the other one is about this particular S100 boards. About the loaning of the hard drive, ultimately it comes down to a question of, really, at the end of the day, there is no guarantee, but there are things that could make me feel better about this. For example, if somehow I could verify that there was a track record, this person had a track record of, doing these sorts of things, or borrowing and returning things in good condition, or if there's some kind of record that I can verify that he's taken training or that he has a background in handling these materials, or perhaps somebody that I know can vouch for him, that would make me feel a little bit better, or his or her participation in the community, if there's a way that I can track it back. So oftentimes, it's unclear. So somebody may write a blog post that's good content that I appreciate and I sort of respect. And if I meet a person in person, they could say, yeah, I wrote that, but there's I don't really know if they're telling the truth or not. However, there could be such, I could easily imagine a mechanism by which they can present a proof that they are that author of the articles. And that would instantly improve, my acceptance of their reputation, that sort of stuff. Of course, collateral is outside of the discussion of verifiable credentials. They could give me $1,000 for me to hold while they borrowed that equipment, but that's not about what we're talking here. So those are kinds of things that I think, for this to come to be, there's a lot of infrastructure that needs to happen. The actual signing of these credentials needs to get a lot easier. Some of the things you can self-attest to. I guess you can sign your own blog posts, so on and so forth. But maybe something like that in the history. Buying and selling equipment. So one of the things that I did think about, going back to that S100 board, you can assign a DID to a physical item, and I'm still tracking down how actually this might happen, but I could see it happening in that each physical piece of hardware gets a sort of a unique identifier that's sort of somehow basically, we're giving a name to this board, right? This is board number, blah, 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 and it's one of a kind. I could probably just make a sticker and stick it on it, or maybe laser etch a QR code or something that uniquely identifies this, and then we can start writing things about this. I can write a record about this item that potentially, I replaced the caps in whatever it was, 2020. And years from now, maybe I'm not even in possession of this piece of hardware, but somebody can look it up and say, yeah, look, that particular maintenance was done, and it was done on this day by this person. That sort of thing, I think, could be useful. And if you're buying and selling stuff, there could be, parties that can sort of verify the authenticity or verify its condition or potentially even verify that it's working. That sort of stuff would increase the value of the item or, bring value to the community in some ways. I pondered this notion of the certificate of ownership, and I guess, if you own an Apple I, that's sort of exceptional case, but there are cases where, a certificate of authenticity on an item is valuable, and those things aren't traded that often, so I don't know if it's, there's any need for instant verification, but I guess, as we expand the scale of all these items, such things, I think, could have value. This is more of from the museum's perspective, for example. You volunteer at a museum, you go through training program, you could actually have a certificate for completing that training, or you can actually have a certificate that records that you volunteered in a certain capacity, and you can actually collect those over the years, and that actually sort of will represent some amount of reputation of the work that you've done with that entity, museum. Say you move from East Coast to West Coast, or West Coast to East Coast. You used to volunteer at the Computer History Museum, and you had held certain positions, you've worked on certain projects, and it's possible that we could have attestations made about these things that will then, put you at a higher standing immediately at whatever new community that you go to. I think that's kind of cool. In general, the verifiable credentials are considered for representing actual completion of, as a certificate. That's one of the sort of low-hanging fruits, conceptually at least. So that's one of the things. But again, if this was to come to be, then so I guess in this case, the museum would actually have to be in a position to sign that, and in order for that to happen, there's all kinds of preconditions that need to happen. The point being that we're not there yet, but I could see this happening soon. Okay. So I'm about to. So this is where I guess we open it up to. Does this sound interesting to you? Do you have any ideas? What would you do with verifiable credentials? Yeah, go ahead.
Is there, or do you see a possibility that somebody who is providing attestation might also be able to provide something like an NPS score? So we talked about this person volunteered. They held this position. Well, just because they did that doesn't necessarily mean that they were good at it, and maybe I don't want them to do that for my organization. So how do we verify the quality of the work?
Yes, I have pondered that. I have thought about that. That's a harder problem. I think there's ways to basically have sort of a thumbs up, and this will be a larger network of things. Your interaction with somebody could be recorded, and actually so I'm a little bit stuck right now on where these things are going to get recorded. I don't see a suitable place, and actually I glossed over on the network page, but at some point somebody has to pay for infrastructure. And how is that going to actually happen? And it's unclear in the entire industry yet how people are going to make money with this, or who's going to pay for these things. Obviously, there's value, and there's values to all the parties, right? The issuer has the benefit of being able to issue something quickly and easily, not be and not be bogged down verifying. So that's the benefit for the issuer. For the verifier, the benefit is that you can verify instantly, and for the holder, you have the benefit of being able to selectively and disclose as well as in a privacy-preserving way. So that's there's benefits for everybody, and it's still a little bit tricky or interesting to see how the payment part is going to work, as well as how we are going to represent quality of.
And there's value there for both the holder and the issuer, because as a holder, I want to actively increase my reputation.
Yes, yeah, and I'm sure there's going to be ways to game the system, and then it's going to be ways to prevent that from happening as well, I suppose. Go ahead.
What I'm thinking is the verifier, now that would be the merchant. Is that correct?
Well, it all depends on the scenario. In my case, I happen to own the piece of hardware that I wanted to loan out, right? And so I wanted to verify something about that person that was making that request.
Right, so there's, somebody's going to be gaining, one of the parties is going to be gaining a fair bit. I wonder if just like a little micro 0.4 cents per transaction, or 1.5 cents or something that's relative to the value of the verification.
Yeah,
Both
yeah,
parties could pay a percentage
yes,
out of their blockchain wallet.
yes,
Everybody would have to have funds in a blockchain wallet. And then these little tiny microtransactions over time could benefit the issuer and the holder and the verifier.
yeah. I think such things can be implemented right now. In the case where we assign, so I talked about that S100 board where the caps got replaced, as an example for being able to assign identity to a piece of hardware. In that case, and actually, so some of the stuff that we do in the vintage community is we're creating a story, right? So I have a piece of hardware that was that my parents bought me when I was in high school. It's a small old. What is it, Epson PX8 or HC80. It's a laptop that runs CPM. It's sentimental to me, and I'm going to eventually pass it on because I'm not going to live forever, and I'd like to have my story attached to that piece of hardware forever. That would be nice. And so I went looking for, is there a mechanism currently to store data beyond your own lifetime? And I haven't found anything yet, but I have found some people that I'd like to talk to about. So, and that I think is a universal. That can happen, and I see it happening in many different aspects in the vintage community, from older machines, bigger older machines to smaller, or even hand-built, one-of-a-kind machines that if it wasn't for the story that was attached to it, it's just a bunch of wires and boards. But I think that there's a lot of added value that by being able to attach the story to the physical object. Go ahead.
I'm just wondering if you've heard of a related technology called WebAuthn.
Which one? WebAuthn, yes.
Not solving the same exact problem, there's some similar mechanics.
Yes, that was about verifying authentication. Yep. Yeah, I have read articles about combining WebAuthn with verifiable credentials. So I think people are working on that too. Like I said, I will be at the exhibit area as much as I can on Saturday and Sunday as well. So come by and we can chat. Otherwise, I thought I'd close with the remark that you know, we will probably be explaining to the newcomers in a not-so-distant future how we used to show our driver's license, or how we dealt with credentials before it was fully digitized. Just like, you know, we explain punch cards and core memory. Thank you very much.